Good morning, everyone, and welcome to day 2 of the Geo Symposium. We're going to start off now with this first town hall session for the day. My name is Mark Dowell. I'm from the European Commission's Joint Research Centre, and I will be moderating this session. So the session is entitled Harnessing Innovative Technologies for Earth Intelligence Solutions. I think we already started to see quite a lot of discussions today on this, and things have actually not only within, of course, the geo community, but more broadly have been progressing very rapidly over recent years. Just to remind everyone that back in, and I know there are a number of colleagues in the room who worked with me when we were preparing the post-2025 strategy. So back when we were first writing that in 22, 23, we already recognized, although I'm not sure to what we could really appreciate to what degree these technologies really will be taking over a lot of the work that we do in the last years. And in fact, there was a quote in the Geo post-2025 strategy where we defined Earth intelligence, which stressed that it should also integrate Earth observations, models, innovative new technologies, including artificial intelligence, machine learning, digital twins, cloud computing, into the design of services that provide Earth intelligence. So as I said, I'm not sure back those 3 or 4 years ago, we could really appreciate to what degree that will be the case, but it definitely has come to be. Okay. So this session is going to look at these technologies. I guess you could say it's the geek session in a sense, because we're really going to dive into how some of these technologies are being actively used across the geo community. And we're going to look at this through very practical use cases from some of our panelists, but we're also going to invite the audience to engage and provide their own perspective on how these technologies are transforming the work that we do. And I'll come back to that just in a minute. I want to already give you an idea of the outcome that we want to get from this session, so that we kind of, maybe you can gauge your own interventions, and the panelists you'll see are also addressing this. And there are really 3 dimensions that I think we would like to be able to address when we're hopefully wrapping up some conclusions to this and then reporting back to plenary tomorrow. First is how we address scalability issues. I think that's key in how we use these technologies. Secondly, we want to acknowledge and understand the issues related to responsibility, inclusiveness, and equity. And finally, really to zoom in onto what is specifically GEO's role and GEO's niche on these aspects. It's obvious that GEO kind of looks at this from 2 points of view. It is, on one side, a heavy user of a lot of these technologies. But on the second side, I believe that also we are driving in certain areas of this technology's progress, the actual technological advancement itself. So the structure of the session is basically going to be, we have some panelists that are going to provide their own perspectives. And you'll see we have a very diverse range of perspectives on the panel. And then with a couple of questions. And then after that, we're really going to open it up to the audience for your input. We would like to take input, of course, from GEO member countries, but also from participating organizations and associates. And then finally, and to some degree, perhaps also most critically, we'd also like to get input from GEO work program activities above those that are represented here on the panel. Okay, so we have in this panel 5 panelists providing, as I said, different perspectives. We have Vincent-Henri Puck from ECMWF, who really will provide that system level idea on how technologies are integrated in services, but also in support of policy and European leadership. We have Yifeng Ban, who is, of course, providing almost the internal strategic thinking on AI in particular, as responsible for the AI and EO activities. And you'll see she'll introduce some of the works that have been prepared on the upcoming strategy paper. Who is a technology enabler and provides kind of really the AI reality check of what's possible and what we should be doing. We have Sven Gilliams from GeoGlam, who is the executive director there, and he'll provide the perspective from a thematic operational agricultural point of view. We have Letwin Pondo from the Geosecretariat, responsible for Africa Youth, for the youth activities, and specifically we'll focus on Africa and the use of VHR. And then we have Grace Saunders-Hosberg, who is really working more on those last mile applications, but also will address some issues addressed to ethics. So I think with that, I'd like to move first into straight into the first question. And in particular, I'd like now to really focus on specific use cases that our panelists can provide from their perspective to hopefully at least provide some stimulus and food for thought as well from interventions from the audience. So I'll start with Yifeng, and I believe we also have some slides that will be accompanying the panelists in the individual interventions, but they're not presentations, just for illustrative sense. So the question is going to be the same to all of them. I'd like you to provide concrete examples of where innovative technologies have become real and provide input to decision-making solutions. So Yifeng, over to you first.
Yeah, thank you very much, Mark, for the introduction. There are many great examples from the AI for EO enabler community. I choose the project that I'm most familiar with. It's my own project. How we use AI-driven Earth observation for environmental intelligence. So this was an actually very unexpected project. I have not, a year ago, I have not thought about working on this. We've been working with AI and EO for change detection for many years. Then about a year ago, the Swedish Environmental Protection Agency came to us, contacted me to say, oh, you do a change detection, you should be able to do this. So they also brought the Stockholm County Administrative Board. Maybe you have heard about the Think Pink scandal, the Swedish queen of trash. She has dumped illegally with her, partners, many illegal sites that amount to 200,000 tons of illegal waste. And last year, the court judgment came, then they have to pay 260 million Swedish krona fine for removal and environmental cleanup. But the cost is much higher than that. The water in the lakes were polluted, soil were contaminated. You used to be able to swim in the lake, but now you can't nearby. So that's what we're doing, is using change detection techniques, using open data, because they say if they pay for high resolution satellite imagery would cost about 100 million Swedish krona per acquisition. So can we do it cost effectively? So that's what we're doing. We use AI using high resolution past event. Now we have collected 400 illegal sites, unbelievable how many, train on them, and we hope we're able to detect ongoing upcoming illegal sites and to save costs and save the environment. Thank you.
Thank you very much, Yifeng. And now I'd like to move straight away to Vincent-Henri with the same question. Thanks.
Thanks, Mark. So I will take an example from numerical weather prediction, which is one of the most mature application area in terms of operations of Earth observation. AI in this field has been revolutionary in recent years. And what I would like to highlight here is the fact that together with a number of European national weather services, we've worked to develop a framework, which is called ANEMOI, to develop AI-based solution for weather forecasting using AI technology. So it's a collection of data sets, pipelines for machine machine learning training and operations, and also for inference. And the precise example I want to highlight here is this forecast in a box concept that we have developed in the context of Destination Earth, a program of the European Commission. The idea is to make fit within a small computer, a laptop, all the handling of input data that you need to do forecast, a trained AI model, the post-processing and graphical routines, and control systems for managing the process. So within a laptop, you can do numerical weather prediction operations. And that's what was demonstrated in particular by the Norwegian Met Service, working in the context of cruise, with an application over Malawi. So this forecast in a box was deployed and is being tested over Malawi with the Malawi Climate and Weather Service involved, allowing them to make operations in their region, which is of course critical for extreme weather. So technology and AI in that case is not only changing, I would say, the workflow of the operation, it's changing the way the players are collaborating, and it's opening new options that were completely out of scope with traditional methodologies.
Thank you very much, Vincent-Henri. And next I'll pass to Letwin.
Thank you so much for the introduction, and I'll head straight into my example, coming from an African region and also from a youth perspective. So VHR, or very high resolution imagery, is no longer just an innovative technology that we just talk about and randomly. We as youth are also using it. For example, I used it in this project. I'll talk about this flood mapping in Tanzania, where I personally used VHR to map the flood-prone areas for disaster response. The project was under the humanitarian OpenStreetMap team, but focusing on Tanzania. So I want to highlight at this point that there's a kind of excitement, there's this kind of fulfillment, there's this kind of curiosity that comes with using very high resolution satellite imagery. It's not like using some other imagery that are not like so clear. You don't have to guess where features are. You don't have to assume there is something when there is nothing. Very high resolution imagery gave us that perspective that infrastructure is here, people are here, communities are here, and it helps us to respond to this disaster also effectively. But also it gave us the experience and important challenge of internet infrastructure coming from an African perspective. But also this is why conversations like what we're having today are so important, so that also young people and also people from different regions and also those regions affected by environmental challenges are not just only end users of these technologies, but are also contributors, innovators, and co-creators of the ecosystem. Thank you so much.
Thank you, Letwin. And now we'll pass to a work program kind of activity perspective with Sven. Sven, go ahead.
Thanks, Mark. Well, first I want to start by saying that it wasn't easy to find or to select one, because GeoGlam is over 100 organizations. So choosing an example is always difficult. There's so many impactful and using cutting edge technology. The reason why I chose this one, also on Malawi, so maybe Vincent, you should look at your tool as well, because climate data is used in this one as well, is because it's a yield model using AI, and that's really scalable. In this case, it was used at national level, so district level, but it's also integratable in scaling it from the basically almost the field level to the national level to the global level, and that's really key within GeoGlam. Another reason why I chose this example is because it's a really collaboration between different GeoGlam partners. On the one hand side, you had NASA Harvest, and you had FAO working together in combination with the ministry. So we were able to use this tool in the El Nino drought, and it helped the ministry to plan their actions or plan their drought interventions in the country by providing yield at district level in a timely manner, so way before the actual problem was visible on the field. And so I think combining new technology, working together with the countries, that is really the way to go for impact, and make sure that the people in the country trust you. So I think this is why I chose this example.
Thank you very much, Sven. And then finally, I hand over to Grace to address this with her example.
Thank you, Mark. So I am an independent contractor and I operate drones. And in my experience with nature-based infrastructure projects, using drones to create high-resolution georeferenced orthomosaic maps has been the most requested deliverable from my clients, who tend to be environmental engineers or ecologists that are often contracted by a land developer. So NBI is a client-resilient approach to infrastructure management. It recognizes that nature can provide many of the same services as engineered services, often in ways that are more adaptable to extreme weather and more cost-effective. For example, wetlands can naturally filter water and help reduce flooding events or flooding impacts. But seeing nature as infrastructure is a paradigm shift for many professions engaged in land use development. In the past and still now, land use decisions were made with limited understanding of ecosystem services, which led to natural assets being mismanaged and their services degraded. And using drone outputs to help understand nature as infrastructure, likewise, is a new data frontier for my clients. So my project onboarding tends to be quite detailed, where a lot of questions are asked, and as they present an information gap, I'll suggest a deliverable. But orthomosaics is always the gateway deliverable because of its high resolution, because they're able to see areas that are difficult to access on foot, and because it's something that can be shared easily and easily understood when they go back to their consultant or when they go back to consult with the developers or with funders. Thank you, Mark.
Thank you, Grace. So I saw Rui have a heart attack when there was that announcement. Rui, do you want me to start from the beginning? No, okay, just checking. So that was, I think, very useful. It provided, as I said, a diversity of different use cases, and started, at least as I was reading and listening to the colleagues, to address some of these issues along those three dimensions that I mentioned. So, for example, Wei Feng and Vincent-Henri, to me, addressed also very much this issue of scalability, that both the methodological advantages of using these technologies, such as for change detection, which has applications, I'm sure, well beyond those that Yifeng showed, and the forecast in the box approach, which could basically use these technologies and be scaled up to many different reasons. Then the inclusiveness aspect that I think Letvin started to address with her intervention, really on the kind of the ownership and the direct association of citizens as they can take advantage of VHR data. And then really also thinking about Geo's role, both from Sven's intervention on how they brought a number of different GEO members, participating organizations together to address that specific application for Malawi using those technologies. And then finally, Grace's intervention on really how these technologies are really helping to address the last mile type of applications with recognizable and reproducible products such as the orthomosaics. So with that, I think we're going to move now on to the second round of questions, which is really, I think we've seen these very strong examples now, but now let's focus on a bit more on these three dimensions that I've just summarized, how we scale these things up and what is Geo's role in supporting the process. And we're going to start this time with Grace. So Grace, if you can provide some input from your work with end users and give us some indications of what are the main barriers to scaling up Earth intelligence solutions that harness innovative technologies and how we also ensure that these are used responsibly and inclusively. Over to you.
Certainly. Thank you. Clearly, I have a gentle touch. So, like myself, when you work at the intersection of the environmental sector and Earth observation, it's easy to overestimate the familiarity other environmental adjacent professions has with EO technology. This area is very fragmented and has nested sectors where we have specializations within specializations. And on top of that, technological advances and behavior change does not occur at the same time. So once you work within a niche, for instance, within nature-based infrastructure, you also need to build capacity and awareness of the capabilities of the Earth observation technology that you use and how it can be applied to solve your clients' problems. Many of my clients still use Google Earth, a notebook and pen and iPhones to collect in-field data because this is what they're comfortable with and they're uncertain about the expense involved in adding new technology to their workflow. And the developers that they work for are even less familiar with EO technologies, and they're also new to the idea of nature as infrastructure. So in my mind, there really needs to be training materials, webinars that use Earth observation technology and products to educate about nature-based infrastructure. The other thing that I wanted to address is integrated workflows. There are several facets to interoperability, but I just wanted to focus on the benefit that it provides in telling a fuller story about the natural world using different data collection methods. I bring this up because there is a misconception among some of the professionals that I work with and that I've encountered who think remote sensing and drone mapping and in-person fieldwork are competitive approaches to data collection rather than complementary. There is an economy of scale with each method where it doesn't make sense to use drones, for instance, to map a 900 hectare parcel of land. But the shortcomings of one is the strength of another. So they don't cancel each other out. They're actually quite complementary. So environmental practitioners need to see interoperable workflows and data collection methods modeled that combine these techniques or these technologies and methods. And I think GEO could support this by sharing practical case studies that demonstrate what these workflows actually look like in practice. And in terms of data standards and frameworks, for drone technology to scale responsibly, data standards and governance have to be embedded at the initial stage. Trust and fair, that helps guide transparency and interoperability and data integrity. But ethics is hugely important, and so is the governance models needed to be, and this needs to be on par with the standards and not just an afterthought. And the same goes for privacy concerns. For me, when I onboard a new client, I have a huge checklist of questions that I ask that discuss whether there is indigenous interest in adjacent land or how to notify people who are living right beside a project area so that they know that their privacy is not going to be invaded. So one instance that we had recently was that we were mapping a riverine area for a restoration project, and we discovered that right adjacent to that property was a house that was a women's shelter. And so that completely changed how we approached that project. And we also wanted to make sure that the people that lived there did not feel as if they were being, we didn't want to invade on their privacy or their sense of security. So I'll wrap up there.
Thank you very much, Grace. So now moving to Sven. Sven, GeoGlam obviously has a lot of experience working with countries. I think you mentioned yourself in picking the example. It was quite complicated to pick one among many. And you also obviously have this multi-tiered engagement, both with countries, international organizations, and things like this. Can you maybe say something about how, in that kind of very complex context, multi-scale, multi kind of needs, you scale up solutions to specific problems?
Well, thanks, Mark. And first of all, of course, AI can help. It made my slide, so that's great. So I put your question in AI, combined it with a couple of GeoGlam stuff, and this is what I got. But the story that I actually want to tell is that scaling does not come along. Well, technology alone does not scale. You need to have a trusted technology or a trusted organization to provide technology. You need trusted methodologies, long-term partnerships to really work, because in GeoGlam we have a number of excellent technological pilots over the past 15 years that have never scaled. And why is that? Sometimes it's just the way certain projects were structured back in the day. They were one-offs. And if there's no ownership by the end user or by the partner, that's where your scaling ends. And so I think for me, the role of Geo and what we try to do within GeoGlam already is be that entrusted broker. We have best practices documents. We work with on webinars, so they're available on the Geo Knowledge Hub, so people can have a look. We have really an open community of practice with experts from all over the world, so that when we talk about an essential agricultural variable, it's not just the European vision of what is, I'm going to say, of what is an agricultural field. Myself, with my background, I have a very European vision of agriculture. If I talk to an expert from the US, he will have an American vision of agriculture. If we then talk to people from Africa or Southeast Asia or Asia, they all have different visions. So when it's really important to bring the community together, that's for me the strength of Geo and GeoGlam as well. And definitely in these, and now I'm going to sound really old, in these AI times, I feel we're back when I started working with remote sensing. Back in those days, you had the free and open data was pixels of 1 by 1 kilometer. And every time you talk to somebody, the thing was, yeah, but next year, ESA is going to launch or JAXA is going to launch the next satellite with this kind of resolution, and that will solve all the problems. And I feel now we're back at, oh yeah, we have this AI model and we push this button and it's going to be solved. It was also mentioned yesterday, I think by UNCCD, and that there's a number of organizations that were contacting them with AI solutions. But for them, it was very hard to decide which would be the better solution, what would help them. And I think that's really where Geo and the Geo community can help be that broker, have some kind of, let's call it a stamp or whatever, that, okay, this solutions, document the different solutions, document what works well, document what doesn't work, where users need to work on. Because I think at the end of the day, for Geo, it's not, we really need to focus on that research to operations. So Geo as a community where we can start from pilots, end up with flagships, go to sustainability. So really run the whole chain. And it's not the amount of new technologies that we develop. That's not, I don't think that's the impact of Geo. It's really the amount of solutions to real world problems that we can solve. That's for me really the role of Geo. And I end with that. Thanks.
Thanks very much, Sven. A number of things came up there that I think are very useful, and hopefully others will reiterate and may come up in the discussion. Okay, now I'd like to pass to Letwin. So Letwin, you already mentioned the kind of the value and the almost like the human impact of using VHR data and how people can relate to that. How do you think GEO should promote within, of course, its mandate and the boundary conditions of how we work as an organization to promote the use of VHR, ensuring that solutions are deployed in a way that are both inclusive and accessible?
Thank you so much, Mark, for that question. And maybe like I highlighted in my example of using VHR in Tanzania, I realized that the experience gave me some realities that we might somehow overlook when we're having this kind of conversations. Many people, young people, institutions, regions, and other communities, they still face these barriers around accessibility, around affordability, technical capacity, infrastructure awareness, and even discoverability of these data sets and tools that we're talking about today. And this is where GEO comes very important. The role of GEO comes really important at this critical moment. One thing I appreciate about GEO is that openness and accessibility are already embedded within its mandate, within its strategies, and within its ministerial declarations. GEO continues to reaffirm the importance of open and free data exchange, while also encouraging governments and partners to increase access to Earth observation resources generated through public investments. I strongly believe, and I hope, and I pray that GEO and its communities include conversations around VHR more accessible through approaches such as multi-user licensing, collaborative infrastructure, shared platforms, and broader access mechanisms that reduce barriers for researchers, for young people, and for other communities that are maybe underrepresented. But another important aspect is the aspect of youth engagement. For your information, maybe, young people are no longer just end users or maybe just observers of all these conversations. They're already using and working with VHR as developers, innovators, and many other roles out there. So these conversations around accessible platforms where they can experiment, collaborate, and contribute have become a necessity. And this is something that we've actually been discussing extensively throughout the ODOC sessions that are ongoing. We had 4 of them yesterday. We are talking about AI-enabled Earth intelligence, national geoknowledge hubs, capacity development, and etc. And in fact, I was also responsible for setting up the GEO survey on the use of VHR that many of you or some of you have already responded to. We're going to have a discussion about that later in the afternoon on one of the community sessions. I think I deserve a round of applause. Okay, thank you. You have to ask if you need something. Okay, which is good. So I would really encourage participants, and I would really encourage each and every one of you to engage in this conversation throughout the ODOC session that we have today. Particularly, we have the youth session that is coming up on Infrastructure, Youth and Geo-Indigenous Alliance. We were going to discuss youth engagement, accessibility, inclusion, and open knowledge, and also the VHR session, our community event that is going to be there later in the afternoon, where we'll continue exploring how innovative technologies and VHR imagery can better support communities. We're going to discuss the results of the survey that you filled in. So please come in numbers, engage, ask questions, and contribute to the discussions. Thank you so much.
Thank you very much, Letwin. We all support a little bit of self-promotion, so please come to Letwin's sessions this afternoon. So I'm just going to jump Vincent for a minute, but I'll come back to you, Vincent. So I'd like to next ask the question to Yifeng. And I think we've seen this also in some interventions from Sven. There are some very concrete things that GEO should probably take positions on as far as how we support the use of these technologies in our work and make kind of clear opinions available to our users and our communities. And of course, inside GEO at the moment, we're looking at defining a white paper on AI for EO, and Yifeng is leading that activity. So can you say a few words, Yifeng, on that process and the role and GEO's role in scaling the use of AI for Earth intelligence, so that it can be done, of course, also in a responsible, trustworthy, and equitable way?
Thank you very much, Mark, for the opportunity to present the AI for EO communities white paper. We call it the living book, AI for EO. This has been a community effort. When we started this enabler last year, officially established, we are growing in numbers. Now we have around 150 members, and we thought about, okay, how do we, help to survey the fast evolving landscape of AI for EO? Can we actually provide a good survey of technologies being used, data sets, benchmark being used, and what are the opportunities, challenges, and future directions? Can we create some kind of reference book for the Geo Knowledge Hub? So that's what we have been doing. So this is the first draft. If you come to the afternoon session, so this is not the right QR code link to the page. So the QR code comes later. This is, if you're interested, you join the AI for EO community. So we have actually a number of chapters. You can see, first we talk about the taxonomy of AI for EO. What are the models? What are the learning paradigms? What are the systems structure, and how have they been used? We presented application cases and many different AI models. We have 9 different kind of AI models plus a section on benchmarks, and also some ideas of which models are good for what, And we have some application examples: biodiversity, wetlands, forest, natural disasters, urban, as well as land degradation, how they have been used. We have 40 people contributing to the Living Book, really thanks to it's a great community effort. We call it Living Book is because things are changing, and we also collect more. We want to collect more use cases from the community. So if you're working with agriculture, with many the water, hydrology, we're missing those. So I'm calling for community contribution to this. And we also identified a number of opportunities and also challenges maybe you have heard of. Let me just look forward, more focus on challenges is data quality bias and also geographic representation, basically more data labels, training, validation coming from global north rather than global south. And also limited model generalization. Maybe some models perform well in the regions being trained, but when you go out of the unseen areas and it fails. So how do we leverage a geospatial foundation model as an example to overcome this transferability problem? And also we need to have better explainability, uncertainty reporting, and also better governance and AI ethics. So I also want to say that, the unique role GL can play is really to coordinate we already have an open knowledge, open data platform. How do we collaborate on that? And users are looking at all the models and which one to use, what do we do? So this is a guide. And also I think GL can help to reduce inequality by maybe supporting getting more cloud credits, infrastructure access, reduce digital divide, and last not least is really support uptake of this technology as enabler. Thank you very much.
Thank you very much, Yifang. I understand that you call it a living book, but can I ask specifically what is the timeline for this? When will there be a version available that you consider complete, even if still living, let's say?
Today is the release of the first draft, so I'm announcing it here, and the link comes in the session in the afternoon. But if you talk to me afterwards, I can give you the link.
Okay, thank you very much, Yifang. Okay, and so then finally, I'd like to pass to Vincent-Henri. Vincent-Henri, of course, you provide a very strong background from the European experience, both within Copernicus and Destination Earth. Can you maybe give some concrete examples of maybe two to three concrete examples where you've seen the scaling potential and opportunity work that maybe could provide lessons learned for the geo community?
Thanks, Mark. Before going into the examples, I would like to maybe reflect a little bit on the success factor that have enabled in Europe the implementation of geo principles in real life. I think it's a combination of necessary conditions. They maybe not be sufficient, but they are necessary. The first one is a dovetailing of programs at European level on science. So we have Horizon Europe, on technology, Digital Europe, and Earth observation with Copernicus in particular. And I think leveraging this European scale capabilities together with national scale capabilities is a very important success factor. Without those programs, probably not much would have happened. The second thing is to have already existing operational lines in the upstream, midstream, and downstream. Upstream with satellite observation, midstream with a number of operational agencies. My first example was on numerical weather prediction, but there are lots of examples like hydrology, air quality, and more. And this operational context with agencies that have mandates is also a necessary ingredient. And the third ingredient, I think, which is equally important, is the building up of an ecosystem of data, an ecosystem of numerical systems, including AI these days, of course, but also an ecosystem of institutions, companies, and individuals that make it possible when an institution wants to operate an operational activity, there will be responders to tenders or grants. So I think these success factors are very important, and I think it's the best way to overcome the death valley that Sven was mentioning of prototypes of things that are very nice, very good, but then they depend on one person, they depend on funding. This context makes it possible to have long-term applications. The one example I would like to take of one of the most integrated or the apex product, I would say, of the Earth observation ecosystem in Europe. It's ERA5, the meteorological reanalysis. This is a very important product for us, delivered as part of Copernicus, because it's basically aggregating a number of factors that make it operational. The first one is that so the reanalysis, for those who don't know, is replaying the weather of the last 80 years and providing these maps with no gaps, very comprehensive to a number of users. I think it's combining a lot of observation, but at the same time, it's very easy because it's gridded in space and time. It's also very well accessible. And the needs for weather and climate information is very ubiquitous. So the result is a big success. In terms of science, the number of citations of ERA5 is 30,000. So that's 3 times more than the second most cited paper in all of geosciences. So it just shows the impact on science, but the impact is very much everywhere. In areas where it was expected, like water management, wind energy, offshore wind energy in particular, but also it's at the base of other things like the AI revolution. This was not planned when we decided to run this reanalysis ERA5. Nevertheless, all the systems today, the prominent systems that forecast weather not only in Europe, but in the world, they train on ERA5. So that's an example of Earth observation data set that becomes almost an household commodity because of these different properties. And there are many other examples. I don't have much time. These days, for example, we are using AI to run scenarios about air pollution. You've seen the weather, it's very hot. One of the pollutants is ozone, and ozone is a complex pollutant because its effects are seen not directly where the emissions are, and it's transboundary. We are here between Swiss and France. And thanks to AI, we are able, and Earth observation, we are able to play scenarios and answer the decision maker. Would it make a difference to stop half of the cars in Switzerland, in France, or in Germany? Would it improve the situation regarding ozone these days?
Thank you very much, Vincent-Henri. And I think one thing that Vincent-Henri alluded to in his last comment that we haven't really perhaps addressed so much in this discussion today is also the value of training data for AI models, and in some cases using Earth observation or Earth observation derived data sets like reanalysis data sets, but in other cases the training data that we need ourselves for implementing a lot of these AI models. So maybe that's something that we should at least think about in the future, how we action that. So just before we move into the questions, I don't pretend to make a comprehensive summary of everything we've dealt in this second question, but I'll just pick up on a couple of keywords. The points that the emphasis Grace put on the need for capacity building and integrated workflows, I think is key, and also showing the complementarity to users of the Earth observation products and in situ or ground-based observations. The points from Sven on the role of GEO as an entrusted broker in bringing these technologies that sometimes people are apprehensive maybe of in this, and kind of guaranteeing the value of the data, and the focus that Sven and both Vincent-Henri came back to on the research to operations pipelines. Letwin made this point again on the value of free and open data and how that enables it, and how we should think about, although perhaps not directly free and open, what models we can implement for access to VHR data in that context. I think Weifeng was touching on a lot of the expectations that were coming from other panelists, in that this new document that will be released this afternoon really provides, although a living document, as Weifeng mentioned, it provides a basis, almost like a blueprint of what GEO could and should be doing on this. And then Vincent-Henri, again, showing the need for commitment at multi-scale, in our case, in Europe at EU and member state level. The fact that there is need for a strong, even though if we continue still to develop, the strong underpinning of operational pipelines, both for the upstream and downstream. And then, as I said, reiterating Sven's point on the research to operations pipeline and avoiding these gaps. Okay, as I said, there'll probably be a more comprehensive summary when we report back to plenary on this. But now we'd like to open up to hear your opinions and voices. And first of all, I'd like to invite colleagues from GEO member countries, if they would like to intervene, to address, maybe with some examples of their own, what they still see as big barriers in adopting these technologies at the level of their country, and how critically they see GEO perhaps supporting them in these efforts. So if anyone would like to come in, please raise your hands. Yes, and I'd ask you, of course, to be quite brief and succinct in your response. Please try and keep it to 1 minute, and also please introduce yourselves before you intervene. Anyone like to take the floor? Okay. Oh, you saw one there. Sorry. I'll pass first to France and then I'll come to you. France, go ahead. Not France. France. Sorry.
Yeah, Franz Simler, European Union. I'm not sure we are a member country. We are a member of GEO, of course. So thanks for this interesting presentations. Actually, I was thinking, I mean, I've been, for example, we had a workshop on AI for EO recently in Brussels. I've been to the Big Data from Space conference, and there are amazing developments there. The technology is moving ahead enormously fast, and actually there's a lot of really useful stuff coming out from them. And I must say, I didn't see this here really. That I think GEO is a bit lagging behind and not adopting this at the pace that is necessary today, where these technologies are moving extremely fast. We have a number of projects that work on this area. We have OEMC, Open Earth Monitor. We have EU4AI. We have BioClima, who uses AI for mapping ecosystems and biodiversity and so on. And I don't see this diffusing into the GEO activities at the pace that I think is necessary. And I would really like us to think, sorry for being a bit provocative, that we need to find ways that we can really pick up this at a much faster pace in GEO, because otherwise I'm afraid GEO becomes irrelevant if we are not able to go with that pace and to pick up these technologies a lot faster than I think currently we do in GEO.
Thank you very much, Franz. I don't know that we need to address that. I think it's a taken point, but I was just wondering, Yifeng, if this is something you have considered in the document, how basically in GEO, which is of course a complex organization of countries, participating organizations, how do we keep up with this pace basically of that things are moving?
Yeah, thank you for your comments. I would say that's not my impression of GEO, even though maybe it looks like that. We did a survey about 2 years ago to the GEO community about how the AI adoption within the GEO work programs, people engaged in GEO. I think if I remember correctly, because it was a couple of years ago, it's already some advanced users within the GEO work programs, and many are at the intermediate level and very few at the lower level. But we feel that we need to sort of speed up this. That's why we established the AI for EO enabler, is really try to bring in methods, tools, data sets, AI-ready data sets, so that the community, it's a lot of resources are out there. How do we introduce that to the community that can scale up things? So that's now we have a momentum. We have 150 plus people within the enabler. And also we now have the living book to show the state of the art. Many of the work we cited are from the GEO community. So I welcome you to take a look at the living book.
Okay, thank you, Yifeng. I think we had Amos. Amos, do you want to come in?
All right. Again, Amos from Ghana. I just want to follow up from Fran's point, because in this particular symposium, in fact, from Ghana, our ambassador to Switzerland was trying to come, but unfortunately she could not make it. And one of the points, critical points that she felt that GEO could really leverage on is the fact that from Ghana, we have recently launched what we call a national AI strategy. Now, the question is, as a country, there is no clearly yet an institution that can really run this show. So it means that there is a connecting point with which GEO could quickly leverage on. Because I also know in Africa, there are a number of countries launching this AI strategy, but which international partner can come in to say that, yes, I have the solutions, I have the room to really promote that, becomes something that we need to take up. So I think the speed with which we need to go beyond the living book and all the things we talk about, maybe there has to be some kind of an official communication from the Geo Secretariat to say that this is the value proposition in terms of what we want to offer to the member countries. That could be one way. But also to mention a point which Seven Geoglam mentioned, that ideas can be very excellent, but the mechanism to build long-term partnership is super critical. I don't know how we work around that, but I think we need it. It is one of the things to be able to scale up, because without that, we can't really scale up. And at least in this room, these are the ambassadors that are going to sell. So we need to think about also a mechanism with which the current initiatives, flagships, and what have you are serving as good ambassadors on the ground in order to scale up whatever we have been doing. Thank you.
Thank you very much, Amos. Yes, before we continue, can I ask for any hands raised? Can you please raise your hands if you want to come in, so I have an idea of how many additional interventions? Is there one there? Oh, yeah, 1, 2. Okay, we'll go here first. Ukraine.
I'm Natalia Kusul, geoprincipal alternate from Ukraine. Ukraine now is in position where AI can help us to understand the real situation, because due to the war, part of our territory is occupied, and nobody understands what is happening there regarding, for example, agricultural statistics and so on. So we are working on implementing machine learning and AI models to monitor the situation. For example, we are working in agricultural monitoring of frontline and occupied territories. And now we submitted ESA project for implementing AI principle and ESA developments for implementation of satellite data for agricultural statistics. Also, now Ukraine is on the way of European association, and we are implementing pilot projects of LPIS system implementation in Ukraine. And due to very time and resource consuming work of traditional LPIS procedure, we try to use automated field boundaries extracted through AI models as a proxy of formal LPIS boundaries in Ukraine. For your questions, what is the biggest barriers of adopting these technologies? We are able to do this due to close collaboration with European and world organizations such as Joint Research Center, NASA Harvest Program, European Space Agency, GeoGLAM Program. We implemented the procedures of in situ data collection according to GCAM principle and international best practices approved by GeoGLAM. And what are the barriers? AI is very resource consuming technology. So to implement it at country level, and Ukraine is a very big country, you should have a big amount of computational resources. And for this, we collaborate and we use Copernicus data space ecosystem. So we are grateful very much for getting us access to this ecosystem. Due to this, we are able to do every year agricultural monitoring for entire country, crop mapping, and so on. And as a scientist in computer science, I understand, and I would be very grateful if we can have such access to cloud computer infrastructure to implement these AI principles in operational mode. Thank you very much.
Thank you very much for that. Yes, I remember seeing a couple of hands over here. Oh, okay, I'll go over there first, Harris, and then I'll come back to you. And by the way, I also will take questions now from participating organizations, which FAO is, of course, and associates. Please go ahead.
Thank you. And indeed, this is in line with previous comments, so I'm following the path. So Livia Peiser, I'm Geo Principal for FAO, Food and Agriculture Organization. And yeah, what I would like to ask the panel to reflect on, or the community, is how we navigate the risk of introducing disparities, particularly when it comes to training data for AI and large language models. We see this for some data that we are familiar with. And for example, I mean, we participate in GeoGlam EAV, essential agricultural variables for evapotranspiration. For example, we see that if you look at the map, a global map of efflux towers that are needed to calibrate the products, there's 2 or 3 in whole of Africa and hundreds or thousands in the rest of the world. A similar reasoning would apply for precipitation and ERA 5. And the precipitation data needs to be calibrated with stations. So how do we make sure that we are not introducing disparities, both in training data and also in computing power? I agree with the comments made by Ukraine in that there's a cost. And how do we support countries around the globe to use these technologies without introducing additional disparities? And last comment is, so in FAO, we mindful of this risk, maybe to some extent, we use a lot AI and use these new technologies, but more for, so far, more for let's say, communicating data and enhancing the experience and interaction of users with complex data, including EO data, and make it more, user-friendly, more than as a data gap type of technology. Over.
Thank you very much. And as I said before, I was, apart from Vincent Rui's intervention at the end on ERA 5, I was conscious that we really didn't address this issue of training data, which I think is indeed very important and a part of the equity issue or quality issue. So I'll take a last question here before we then move on to the work program activities from Harris. Go ahead, Harris.
Thank you, Mark. First of all, I would like to agree, of course, with what Franz told before, that there is a great evolution in the domain of AI. We see that, we experience this every day. However, I don't think that we are rather mature yet to continue to very operational and much adopted solutions. I say that because, I mean, today in my institution, for example, we are dealing a lot with the development of AI technologies for many different cases of mapping and analysis of big satellite data. We're receiving hundreds or thousands of data on a daily basis in our institute. However, the problem is, I mean, how mature are the technologies of getting really something that it is useful for the end user? I have to tell you that one of the big problems we face today, I mean, of course, Funk already mentioned several of the challenges we still face regarding explainability, fairness, and all what these technologies actually include. But I mean, the computer and the computer needs and the computer facility demand is really very high today. I'm facing on a daily basis the need of investing more and more into the computer facilities for involving the processing to faster and bigger number of GPUs, etc., which is indeed, I mean, not for unaffordable cost. And last but not least, on one side, we face this type of problem. of course, we have to move towards developing the AI technology into the daily process. And I mean, like in the projects that have been awarded recently to us, a lot of what we are going to do is based on AI and generative AI. I mean, it's in any case, I mean, part of what we are going to do in the very near future. But I think as a last note on my side, but I think yet very important, is the engagement of the user. I mean, we're struggling years for developing services for the users, but very little of this is really useful because they stayed next to us for years developing together things. And I think this is the biggest challenge, that we will continue developing with them, and especially the operational user, the user that co-designs, co-develops. I mean, I know I'm using trivial, I'm using terms that have been used many, many times before, but this is the reality. Thank you.
Thank you very much, Harris. So as I said, I'd like to bring now the GEO work program activities into the discussion, and specifically maybe to think about it really from a point of view of the GEO work program implementation. So how are you using these technologies? What do you see as issues? And really addressing those three levels that we wanted. What is the scale? What are the scalability issues? What are the issues related to responsibility, equality, and equity? And then finally, GEO's role as a whole and your role maybe together with other work program activities you're interacting with. We already, of course, heard Sven's inputs on this, but I'd like to hear from other work program activities. Anyone? Michele, GEO Human Planet.
Yes, thank you, Mark, and thanks to the panel. Michele Melchiorri on GEO Human Planet. Innovative technologies always come with opportunities and challenges, as we know. Within Human Planet, we are trying to prioritize innovation around informality and vulnerability of human settlements. I appreciate one of the earlier comments about targeting the use of innovation to address policy challenges rather than the amount and the quantity of demonstrations within GEO. So in your views, how can GEO work program activities work together and closer, especially those that prioritize innovation and those that try to prioritize policy support? Thank you.
Okay, there was also a question in there. I don't know, Sven, if you would like to answer this. What do you see as this balance between using these technologies in innovation and more the policy support aspects?
Well, thanks for the question. There's a lot going through my mind. I first want to respond back to Franz's remark, but I can only talk for GeoGlam. The amount of AI used within the program is huge, and I think there's quite a lot of cutting-edge technology there. Natalia spoke what we're doing in Ukraine. You have World Cereal, an ESA project that has scaled, that is now doing seasonal crop type mapping at global scale, 10-meter resolution. That's not possible without AI. The more interesting part is that through GeoGlam, there's a combination of European developed model with a US-based developed model that really strengthened the scalability and the adaptability of the project. So there's a number of cutting-edge technologies. What I tried to focus on my talk was what is the impact, because we also have to be honest. World Cereal is an ESA project. It's going to end this year. If there's no other support from somewhere else, that is going to die. There's a number of possibilities on European infrastructure to come as a payable service to run that project. But if that doesn't take off, it's gone. Well, I hope it's not gone, but so that's one of the points. Field boundaries. Now we have an AI model, also combination of different organizations that does field boundaries at global scale. What is the accuracy of that? Still to be, well, I know what the accuracy is going to be in Europe, but in other parts of the world, that's going to be different. But then we also have to talk about ownership. I can push one button and have that field boundaries. If I have the computer resources and the money, I can do the crop type mapping at global scale if I have the resources and the money. But then I go to a country and I say, here you go, here is your crop type map. They're not going to accept it, and rightfully so. That's where Harris comes in with co-design. You need to be able to do so. I think the cutting edge is in GeoGlam is there. It's translating that cutting edge to usability, how people can use it. That's really key. And then coming back to Michele's question, one of the things that we're doing today as well is a planning meeting between different. We called it the land-based work program activities. It's a discussion that started, let's say, the first real discussion started in Rome last year between GeoGlam and GeoLDN on, okay, how can we better collaborate? Because also there, if we work together in different countries, it's strange for people in a ministry that one day you have somebody with a GeoGlam hat asking questions. The next day, GeoLDN is there, and then GeoBon is there. It's all some kind of geo, but different flavors. So we need to coordinate that, and that's one of the things: capacity building, who to reach out, what are your contacts, using the geo-regional approach to expand in certain regions. That's what we're going to try to do so, and then bringing together policy and users and technology. Thanks.
Okay, thanks very much, Sven. Are there any other questions from Geo Work Program or questions? Are there any interventions, sorry, from Geo Work Program activities? No, I don't see anyone. Are there any other reactions from the panel on the various interventions that we've heard, apart from the ones Sven just provided? Did anyone want to follow up on any of the interventions? I don't. Yes, Yifeng?
Yeah, I would like to follow up about, the challenges raised by Harris and FIO and again by Fran in terms of how geo community like where we are and how we can, move forward. In terms of reducing bias, there are like many approaches that can be used. For example, the geospatial foundation model, you train a large amount of, satellite images pre-trained, and that can help to be transferable or, moving to the areas with limited levels, still can produce result. And I want to say the AI for EO community is actually leading in this development. We have a CACHF here from Cambridge. They have developed a well-known Tessera model. And also my group and some collaborators, we developed a global benchmark on geospatial foundation models. There are many foundation models, and which one is good for which applications. So they are, I would say, GL are leading many of the technological development, as well as benchmarking and creating data sets.
Thank you, Yifeng. Okay, I think we're coming towards the end of the session. I'm not going to make a wrap-up of the wrap-ups. If you want to hear that, then I'll probably be saying a few words in plenary tomorrow morning. But I am very grateful, first of all, to the panelists. I think they really provided diverse and very useful input into the discussion and some excellent use cases. I'm also very grateful to all of you for your input to this session. And finally, I'd like to personally thank Rui, who really has been driving the preparation of this session. So thank you very much, Rui. So a round of applause for all. And I think you have a coffee break now? Yes. So we'll see you in the next session.